Hi, this is Justin again with Ocean Works Marine Air Conditioning, and what we're going to be showing you today is a completed install on a 2019 Explorer 248 Eastern. So come on board and we're going to first look at some of the choices that were made by the customer. What they wanted to do was accomplish cooling the cabin air and out this. If you notice, there's an outside enclosure. So the goal was to cool both areas of the boat. So what we're going to be talking about today are a lot of the fundamentals that go into laying out the installation aspects of the job. So things like the power that's supplied from the dock side to the boat, how that power wire comes into an AC panel, whether that panel is existing or it's one that we need to install. From that AC panel, we're going to be able to bring in power to the air conditioner. So we'll talk about where the air conditioner goes in the boat, the return air that's going to supply the cabin's return air back to the system, the grill that's for that. We're going to talk about the ducting and how the ducting is supplying air vents through both the inside cabin, in this case, and into the outside cockpit area. We have to address an issue with condensation, which is developed from air conditioning. So typically that runs into the bilge, and we're going to walk you through that. Also, with every marine air conditioning system, you have to lay out and design a water application because we utilize the seawater to cool the air conditioner's heat exchanger. So there's a through hull, a water strainer, and a pump. The pump is activated by the system and pumps water to the air conditioner through it and overboard. So it's all of those components that we'll also address. We'll start first with the power. Power comes in from a given pedestal on the dock, either 30 amp or sometimes a 50 amp service. Most boats are a 30 amp service that supplies 115 volts to the AC panel. In cases of a 50 amp, you're able to convert a lot of the loads in the boat to 220, which is a lower amperage or draw on equipment, especially with the air conditioning. But you can see down here that what we've got is a 30 amp service that was installed that the shore power cord will be able to plug into. It's just a surface fitting that allows the power to enter into the boat that has a cover that flips down. You can either get that in a plastic white like this, or you can have it done in chrome. From that service, a 10-3 gauge wire, which is a heavier gauge wire, is routed from that service through the boat, strapped and hidden to what is an AC panel. So again, from the 30 amp service, we've routed a wire to this base panel made by Blue Seas. Most boats, or some boats, already come equipped with an AC panel. In this case, we had to install a panel. There's different configurations with the panel sizes and dimensions that are appropriate to wherever we're going to locate it in the boat. In this case, the customer wanted to have the panel in this location, and there are panel options as far as having meters that can show you voltage and the equipment draw as the loads are turned on. In this case, we have a 30 amp main breaker, and then we have 4 sub breakers with the potential to add 2 more. On the sub panel, we've added air conditioning and tagged it air conditioning. So once we had this panel installed, we were able to then route a wire now from a circuit breaker, a 20 amp circuit breaker, to our air conditioning system. As far as application is concerned in this particular boat, the customer wanted to cool not only the front cabin of the boat, but he also wanted to address the cooling of the cockpit. The 2 panels in the rear back behind the cockpit are isinglass, and they are able to completely seal this cockpit off with zippers. So it's very reasonable to, as long as where the unit is located, I'm able to do some ducting to this spot, be able to cool this area in addition to the front cabin. In some cases, boats where we have to address just the front cabin with an air conditioning system, and then we also have to have a secondary system that addresses just the cockpit. But in this case, we were able to utilize one system that's located in the first locker that we come to address both spaces. So following me into the cabin here. We're addressing the inside cabin. We're going to take a picture of the entire span of the inside cabin so you can get a feel of what the space is inside. And we're going to talk about where we were going to locate the air conditioning system and how we were going to do those fundamentals that I had talked about before. We're going to talk about unit location. Unit location is going to end up being inside this storage locker. The customer had an option of locating it outside in the storage seat, but the customer had wanted to locate it inside this and didn't mind sacrificing the storage because it is a hanging locker. Either location in this case would have worked, because we could have put the unit in the outside storage and run the ducting into this locker and then split it for what we needed to accomplish on the supply side. We could have done return air on the outside out in the front of this compartment and met all the other issues of water application and overboard and power. But again, we've located the system on a constructed shelf inside the locker. We built a foundation support with cleats on either side that are through bolted to the locker. What we do is typically put in a rubber pad that acts as a barrier for the bottom of the unit to create an insulating factor to the stainless steel so it doesn't sweat, but it also creates a vibration barrier to keep the noise to a minimum. The air conditioning system, as you can see in the locker, has a 2-vent application as far as the supply side. We've got one vent coming right off of the blower going forward into the front. You can see where we've cut that supply. That single vent is going to roll the cold air around the whole bow of the boat and around back into the return. Down below here you do see the return. That's going to be able to take the hot air from the cabin and recycle that back across the evaporator. We could have put a return, we did put a return air here, but we could also, in addition to that, possibly cut a return air into the top of this locker, because hot air rises, and that would be also an additional area where hot air from the cabin can be pulled back into the space. So as discussed, we talked about the forward vent that is going to cool the cabin, but we also have another vent that's coming directly off the blower, that's coming out to the outside cockpit area, that will cool the entire area outside. Now, on this boat, the customer and we discussed cooling both spaces. In some cases, a customer may prefer just to cool the cabin. In that case, we may have been able to go with a little bit smaller BTU, probably in this cabin space down to at least a 7,000 BTU. We increased in this boat, because of addressing the outside cockpit, we went up to a 10,000 BTU. So this is the location for the air conditioning system. As you can see also that we mounted the control box, which is where from the power panel, the power wire comes to this location. The thermostat wire goes from where the thermostat is located to this control box. The power wire for the pump, the seawater pump, comes from that control box down to where the seawater pump is. And then we just found an appropriate location to mount that control box, with the intention of later being able to put in a cleat that would be able to put in then a shelf, so we can have the ability to maybe retain some of the storage aspects of the locker. So what I'm going to show you next is what we've decided as far as a water application that supplies the seawater that's used to cool the heat exchanger at the air conditioning system. It's very common in every install that we put in a through hull, a water strainer, and a seawater pump. That pump is activated by the air conditioning system when you turn on the equipment and pumps seawater through the heat exchanger and then overboard. So in this particular boat, we located it down in the bottom in the center compartment here. You'll be able to see, first off, to the left side, we have where we've mounted on the pad support, 3/4 through hull valve. That's a safety valve that allows us to be able to bring the seawater in, and then also be able to open and close that valve for safety closing the water off and then also bringing the water in. In this case, we elected to bring the fittings, all brass, up to the strainer and hard fix mount it, the strainer. The water strainer is there are various different sizes and configurations of the water strainer, but basically what its design is to just roughly filter the water before it enters the seawater pump. Again, they come in different configurations. We used a Sherwood style where the basket unscrews counterclockwise and you're able to clean filter screen that's inside of that. This particular part of of air conditioning is an important part because gaining access to that strainer for routine maintenance is an important factor in how this is all laid out and designed, and the choices that are made with the different components. So from the strainer, from the through hole rather, in through the strainer that we chose, we now bring 3/4 braided hose, double hose clamped to our seawater pump, which is a March seawater pump. It's what's called a March AC3, 115 volt. The factory offers a 1-year warranty with that seawater pump. And what we've done is we've actually elevated the pump onto a support system to create more of a parallel effect from the strainer to the pump, so that when the boat goes in the water, it automatically primes the impeller housing of the pump. From the pump, we've attached a fitting we use all marine 5200 sealant. We end up routing that hose to the air conditioner, but as it leaves the pump, we actually install what's called a primer valve. It's a bleed-off valve. That's in what we call as a bleed-off valve or primer valve. What that enables us to do is, as the boat is lowered into the water, there can sometimes be an airlock that comes into play from the through hull to the pump. And by having that access valve, you're able to turn that valve and bleed off any air pressure that's in the water line, the intake water line, allowing the water to freely flow into the impeller. Because the seawater pumps are not self-priming pumps, they have to be given the water, and then when they're activated, they supply then the water to the air conditioning. And next, what we're going to talk about is the thermostat. The thermostat is what you'll be using to activate, to turn on the air conditioning system, both in cool and in heat, and be able to set the temperatures according to what the customer desires. In this case, we located the thermostat on the opposite wall, just because of customer preference. He wanted it close to the other chrome matching fitting and wanted to be able to sit in this location to make the adjustment. In a lot of scenarios, what you're looking for is just an interior spot where a customer can comfortably address the thermostat to make those adjustments, because the thermostat actually doesn't have its sensor at the thermostat. The sensor that's measuring the temperature in the boat and is located at the actual equipment. It's a little bulb copper sensor that we place in front of the evaporator. So it gives us the versatility to put the thermostat in different locations that can be kind of away from the thermostat or from the air conditioning equipment or close to it. It doesn't matter. One of the other options would have been potentially to the front edge of the storage locker. The thermostat could have been on this side, about in this location, where they could have sat on the bench and addressed the thermostat here. The customer just had the preference of putting it over here. So the basic functions of the thermostat are just generally that there's a power button where you can turn on the equipment. The screen is an LED and it goes blue for cool. It actually goes then, if you hit the mode button, it'll go to a fan setting, which is more of a white. And then finally, if you want to go into the heat option, it is an amber lime green color. So there's 3 mode functions. We're going to go back to the cool function there. So then the next button would be the fan. You have an option of 5 adjustments to the fan, 5 speed settings, and you can hit as you hit the fan button, each setting comes into play. You can see it's correlating there. Up to 5. Once you reach 5, you actually have another setting that is the automatic function. If you hit the fan button one more time, the bars start ascending. And what that has done is it's put it into an automatic mode where as the boat is cooled down, the blower will slow its speed down automatically. And it just makes for a quieter run time, especially in the evening hour when you're trying to sleep. So finally, we've got just the up and down arrow buttons which adjust the temperature. The thermostat shows on the screen the ambient temperature of the boat, and that's related to that bulb sensor that's by the evaporator. But then you've got the two up and down arrow buttons that let you walk your set temperature down to whatever degree you want to keep the temperature at in the boat.